Okay, welcome to Introduction to Service Meshes. Let me quickly introduce myself. Like Todd mentioned, I've spoke at ATO, I think, for the past 4 years about Istio and Service Mesh. I recently started with Solo.io. I've been a long time IBMer for 19 years. I actually wrote a book, Istio Explained. So check out my book. It really helps you to get started with Service Mesh. And I've been a long-time contributor to the Istio community. I also have 200 plus IBM patents, well, my work at IBM. So Solo.io, Todd is absolutely right. It's really into the service connectivity business. We're really trying to push the boundary of what service connectivities can do. And my main role at Solo.io is on open source side, continue to contribute to Istio. Okay, sorry, my keyboard wasn't responding fast. So we're going to talk about thought process for learning a service mesh because you're here to learn, right? So we're going to talk about what is a service mesh, and then have you think through in your organization, do you need a service mesh? And what are the service mesh projects available there, right? Assuming your organization maybe needs one, or maybe you foresee you're going to need one soon. And then where are you going to get started with service mesh? And what are some of the surprises as you start to trying service mesh you might encounter? I want to give you some heads up. And then we're going to talk about benefits, just to recap. We're going to talk about benefits along the way, but we're going to recap on the benefits and some of the next steps you can take to continue your learning on service mesh and Istio. So let's start with challenges with microservices. So as Kubernetes become the application server, right, for microservices, there's a rising set of challenges within microservices. The way users are thinking as developers and operators, they're thinking about how they are going to observe the interaction among their services, because it's not one monolithic. How are they going to secure the communication of their microservices? How do they do zero trust network, allow their services to communicate securely? How do they manage timeout and communication failures? Because your microservice is going to be distributed among multiple regions, multiple zones, and the network connections are not always going to be reliable. So you kind of have to think that as you go from monolithic to microservices, and how do you control that traffic shift, right? Because you not only have one destination, you might have multiple versions of your services. And as you transition from monolithic to cloud native, maybe some of your traffic are served from your monolithic and some of your traffic are served from the microservice. So what exactly is a service mesh? The service mesh really provides a programmable framework to allow you to observe, secure, and connect to your microservices. And what's really important about service mesh is the framework supports multiple languages of your microservices. So it's language agnostic regarding which language your developer choose to use, and also providing the observe, connect, and secure consistently, regardless which language you choose. So that's the most important thing about service mesh, is providing this programmable framework, allow you to programming your service mesh consistently and gaining the benefit to secure your microservices, to connect to your microservices and observe what's going on within your microservices. So service mesh is really solving your application networking problems, problems such as service discovery. How do you discover services among your microservices? How do you load balancing among your services? And also, most importantly, to the specific way you want to be load balancer. And how do you secure your service-to-service communication? How do you do traffic control among different versions? How do you do weight-based routing, right? Without relying on Kubernetes number of replicas. How do you do traffic shifting? How do you do traffic shaping and mirroring? A lot of advanced scenarios that service mesh can provide within traffic area. And how do you do policy control? How do you do access control? How do you do metric collection so that you have visibilities to your tracing, your dashboard, how your service interact, which service have problems that you can pinpoint quickly? How do we increase the resilience of your services so that maybe you have timeout and retries, you have outlier detections, so you can fail over when local services are not healthy, you can fail over to the next closest service within your data center. And also finally, service mesh providing all these through a programmable interface that you can program the service mesh to do these type of things through the service mesh API. So how does a service mesh work? Essentially, there are control plane, which is what you interact with. The control plane typically runs in Kubernetes, but it doesn't have to. But if it's in Kubernetes, you normally programming the control plane through Kubernetes customer resource, and then you use the kubectl command to deploy your service mesh customer resource into the service Kubernetes cluster, and then the service mesh control plane will be listening and processing the service mesh customer resource. And most importantly, it actually takes actions on those resources and translate those resources to the proxy configuration that your proxy can understand. So different proxy speaks different languages. For example, Envoy proxy, multiple people spoke out Envoy proxy configuration are not intended for human. So they're extremely complicated. By interacting with service mesh control plane, you can program the control plane, which in turn programming the sidecar proxy to do any of the service mesh functionality we talked about earlier. So the bottom layer, what we call is the data plane. So service mesh is going to be intrusive because you're going to need to inject that sidecar proxy next to your application container. So the way it works is whenever the app reaches out to app 2 in this diagram, it always goes through the sidecar proxy. So the sidecar proxy is there in the middle to mediate the traffic, to be able to enforce security access rules, to be able to collect telemetry data. So all the magic we talk about to be able to connect, secure, and observe are done through the sidecar proxy. And that's how service mesh was able to achieve these functionality regardless whether which programming languages your application are using. Now, after you learned a little bit about service mesh, the next thing you probably are thinking through, do you really need a service mesh? The answer is actually, we don't know. Only you can decide because it's really based on your business needs. And are you building microservice architecture today? Do you have multiple frameworks? Do you have multiple programming languages used by your developer? And how many services do you have? If you just have one service, probably not worth to run service mesh because you have to kind of operate that control plane or pay somebody else to operate that control plane for you. Microservice, unfortunately, it's going to be complicated because microservices run distributed and the network are not always reliable. So you have to kind of manage that complexity. So if you have a lot of service mesh, if you have a lot of services, if you have services in different programming languages, this is where service mesh could be interesting to you. Are you running cloud native? Are you using containers? What are the interactions among your services? Are you using TCP or HTTP? Or are you using REST? Or do you need to secure communications among your services? Do you need to kind of have a consistent policy enforcement among your services? And what are the scales you have? Do you have large scale set of services? Is it difficult to apply policies consistently today? What about metrics collection? Are you collecting metrics? Do you need metrics collection so you have visibilities to your services? So these are the questions we want you to think through, and only you can decide whether you really need a service mesh. So you may come to say, you don't really need service mesh today, but we want you to keep an eye out for explosions in number of services in your organization. We want you to keep an eye out. Are you maintaining multiple programming languages for networking libraries for your services? Because these programming language libraries are very expensive to maintain. They're very expensive to develop. It probably takes one person per year or two person per year to develop. And it also takes a long time to maintain. So definitely watch out for those. Are you building and maintaining complicated certification management system? How are you rotating key and certs used by your microservices? Do you need better observability between your service interactions? So we want you to keep an eye for these things, because these things could mean you may not need service mesh now, but you may need it soon. Okay, so we talk about keep an eye out for these things. I also want you to think through, do you have supporting infrastructures, right? Do you have Git or a source control system? Do you have a CI/CD pipeline? Do you have artifact repository? Do you have existing logging and metrics and tracing system? Because these are the system you kind of work with service mesh. So it's going to be critical to have them in your infrastructure to adopt a service mesh. Finally, one thing I want to say, service mesh is a very critical piece of your infrastructure. So remember, we talk about the data plane, right? The sidecar proxy is going to be injected next to your application container. So the fact that you are adopting service mesh, that means you are adopting the sidecar proxy, and it's going to be part of your workloads. So it's going to be very critical. So you definitely want to adopt one, with a lot of process in place. So assuming you do see value of service mesh, right? You've gone through the thought process of, whether you need a service mesh. Let's talk about how you can select a service mesh. So we talk about Envoy proxy or any other proxy in the data plane, right? It's a critical part of your infrastructure. So you want to select something that makes sense to you. So we've seen a trend of Envoy proxy and something else as a proxy in the service mesh industry, right? So if you look at most of the service mesh from Istio, Open Service Mesh, which is primarily sponsored by Microsoft. It's also a CNCF project now, and HashiCorp Console and AWS App Mesh, which is proprietary service mesh on AWS Cloud, and Kuma, which is a Cons service mesh. So all these service mesh landed using Envoy proxy as the sidecar proxy. There's also Linkd and Traffic. They landed on their own proxy of something else as their proxy. So you want to decide, whether Envoy proxy is, I think it's certainly, the most dominant service mesh sidecar proxy today, and Envoy is also very hugely successful, and it's very well battle tested in a lot of production environments, including Lyft. So that's a start process you should go through. The other process I want you to think through is maturity, right? Production deployment, because if you want to go service mesh, you're going to deploy service mesh in your production one day. So you want to look through, which stage these projects are, right? Being working in this industry for a long time. And I do know Istio has been around for 4+ years. Linkd, I think it's been also around for a long time. Some of the other service mesh projects are a little bit newer. They follow the footprint of Istio and Linkd. I think Console is the next one in terms of maturity and adoption. And then Kuma and Open Service Mesh, I think they're very, very new. If I remember correctly, I think they were launched last year sometime. So very new. So that's why we put them in the emerging category. You also want to look at production support, right? Do they have multiple vendors backing up the project, right? Do they just have one vendor? And maybe it's not even having any support backing it, right? Because you're probably going to need somebody to help you with your adoption because service mesh is it's complicated. With microservices itself is complicated, and it's a critical part of your infrastructure. So Istio is multiple big vendors, Red Hat, which is also part of Istio, right? IBM was a funding company along with Google and Lyft. So it's last time I checked, it's like 300+ contributing companies for the past year. So very diverse community. There's also a bunch of single vendor, Linkd, Kuma, Console Connect from HashiCorp, and AWS and Traffic. These are single vendor, so primarily contributing by that particular vendor. There's also Open Service Mesh. As far as we know, there's currently no support. It's a project out there. You also want to look at Kubernetes support, right? We talk about Kubernetes is becoming the application server for containers and the applications. So the fact that the service mesh supports Kubernetes is going to be important for you as you move down to the journey of containerized and cloud native. You want to look at VM support because most likely you're going to have workloads on VM. Most likely a lot of monolithics are on VM. You're probably onto this transition journey if you do. So this is important to look at VM support in the service mesh. And you can see we rated Kuma, Console Connect, and AWS App Mesh pretty high on VM. And Istio supports both VM and Kubernetes. And there are certain service mesh without any VM support. So CNCF KubeCon North America towards the end of the year did a survey and about service mesh and cloud native. So we actually took the data, the raw data, and find out the people who are adopting service mesh in production. They actually give stats of 42% are using Istio, 22% are using Linkd, and 16% are using Console. As you can see, Kuma and some of the service mesh, like the Open Service Mesh, there's not much adoption. So this maps to the diagram that I was showing early on, production maturity, right? So assuming you do think Istio is becoming the leading service mesh, the next question I want you to ask is, where are you going to start with Istio? So we want you to think through, start at the edge first. because that's the most common way people start to adopting a service mesh is, and also it's less intrusive, because if you look at this diagram, we're not changing your service ABC, we're just using Envoy as the ingress point to entry into your services. But Envoy is a more intelligent load balancer and proxy, right? So it can work on layer 7. So we definitely recommend you to start at the edge, so that gets you explore a little bit more on the intelligent feature for Envoy. And after you start to adopt it at the edge, we want you to think through a specific user case and iterate. It's important to pick one user case and iterate, because service mesh provides a lot of functions. So it's super critical, just pick one and iterate among a few of your services and provide best practice for your organization. So you want to focus on what your organization needs and not the buzzword, right? A lot of our users are adopting, for example, mutual TLS among their services. So that's a common pattern. Some of the users just want to gain visibilities among their services. So they want to adopt for telemetry collection. And some of our users wants to adapt for resilience control. So all these are valid scenarios. As you can see, you are going to be adopt one service at a time. So that this is why, you may inject a sidecar proxy to service A canary running side by side with service A. And then so your traffic are not, impacted. Your service A can still not being touched, where you send up another one on the side. And then once all the testing pass, then you can remove the service A and promote the canary to be the service A with the sidecar. We also want to think through how your team going to integrate with Istio after you play with Istio for a few services. Maybe focus on one function first, because you're going to have a centralized platform team who most likely going to help you to define adoption strategy for your service mesh, and then provide guidance for each of the service teams. So your service A, B, C, these are the team who owns the individual services. So we want you to think through, what are the resources and functions, and who's going to provide in what, and what are each team needs to learn, because the goal is you want to minimize the learning from your service team so that they can focus on their core service, the business logic within their services. So can you promote self-learning with your service team, that the platform team pre-describe, this is how the service mesh should be adopted, and this is the only learning I need from you. Maybe just configure the routes, how other people going to routes to you, and anything else, I want to prescribe for you as a platform team owner. So what are the surprises as I start to learning and adopting Istio from working with our users, right? So one thing we talk about, your proxy and your application container are going to run side by side within the same pod namespace. So proxy may start after your application container start, which means your application container may not get networking traffic, or maybe the traffic are not secure if it does get traffic going out. So this could be a surprise for you. And then your proxy may stop before the application container stops, because today Kubernetes doesn't provide a way for us to control the start and stop sequence between containers within the same pod. So this is something we're working with Kubernetes community to standardize, but you do have some limitations today. With Istio, we do have a feature that allows you to enable configure your proxy to make sure your proxy start first and your application container start next. So we do have an intermediate solution for that. For stop, we typically recommend user to put some sleep in their pre-stop hook. So not elegant, but could work. Container networking behavior, we actually changed behavior in Istio 110 so that the container network behavior same as Kubernetes. So if you're running in Istio 1.9 or prior, make sure you check out the requirement of require your application, especially stateful set to listen on local host, which is not great. And the other thing we all use to find out is, oh my gosh, the sidecar proxy actually retries my request 2 times for me by default. So there are default timeout and retries. These things might come as a surprise to you. So we want you to consider those and disable or adjust as needed. Istio has very rich APIs. It might be a little bit harder to navigate at the beginning as you're learning different functions of Istio. So at the edge, the ingress, we talk about, well, we recommend you to adopt service mesh first. There are gateway and virtual services to allow you to configure, what are the hosts, what are the ports on my gateway, how the user going to get to my gateway, whether it's pass through or whether it's terminate, whether it's mutual TLS or TLS, and what are the routes configuration for this particular path that's through virtual services. So once you configure the edge, the next hurdle, if you're adopting Istio for mutual TLS, you're probably going to learn peer authentication policy. There's also authorization policy. If you adopt Istio for traffic shifting, you're going to pick up virtual service again and destination rule to allow you to configure routes and destination. And if you're working with virtual machines, non-Kubernetes workloads, external services, then you're going to learn service entry and workload entry. So there's a lot of concept. This is also highlights the importance to focus on one thing and do it well before you learn other stuff, so you don't get overwhelmed. So what are the benefits? Let's quickly recap. I'm actually still a chat from one of our user, T-Mobile, because they actually adopted a service mesh with 100 clusters. They really observed a lot of benefits with Istio, with 50% reduction in their MTTR, and they're saving a lot of engineering hours. The main thing is because they're delegating and they're trusting service mesh to do this observe, secure, and connect functionality for them, and they are gaining consistency. They are gaining focus on their business logic because they don't have to solve these problems within their application. And they are leveraging, the extensibility provided by Envoy. A lot of innovation are happening in Envoy with filters, WebAssembly, so they were able to leverage all that. So what are the next steps? So we do have Istio badges offered by Solo. So actually very instrumental as part of this workshop program. So there are foundation for Istio. There are also essential for Istio. So foundation for Istio teaches you to get started with Istio, and essential for Istio teaches you how to deploy Istio in your production for best practice. So if you're interested in sign up a workshop at solo.io. And we're also providing enterprise Istio production support, our company. So you could use upstream Istio, and we provide like FIPS, different build. We're providing long-term support for Istio, which including like critical security patches. So if you're interested in Istio, it might make sense to have somebody else to kind of supporting you on the journey. I think I have a few minutes. I would like to show a quick demo. I know we're running a little bit of our time, but this is the Get Started with Istio workshop that I discussed. So you can actually install Istio. You can have an environment if I can get this environment up running, so you can actually have an Istio environment quickly, and it also shows you like step-by-step guide on what you need to learn based on our best recommended practice of adopt Istio for ingress gateway, and then gradually adding services to the mesh. Sorry, I should start it a little bit earlier, but I'm ready to take some questions if there are some questions. So we'll see how, if I can stand up the demo environment too.
Lynn, I'm looking at the Q&A feature, and Pradeep back at about 12:30 said, can service mesh be configured to communicate between VMs and containers?
Yeah, that's a great question. Yes, the answer is yes, you can run the sidecar. So first of all, depends on how you define the communicate, right? So there are multiple ways. So one critical thinking I want you to think through is, do you want to, depends on what features you want to gain, right? Do you want mutual TLS among your services between your container and VM? If the answer is yes, we recommend you to run Envoy proxy on your VM next to your services on the VM, right? So you kind of delegate the functionality that service mesh provide through the Envoy proxy, like mutual TLS, rotate my key and certs, be able to shift traffic. So this is why there are workload entry to allow services running on the VM to onboard into the service mesh. So Istio definitely provide functionality around that.
Yeah, if I think he had a couple of follow-up comments, and I should have mentioned this when I was when I was saying what I said, like KubeVirt VMs. That was an example, and then I think he had a follow-up comment at 12:47 just a few minutes ago.
Okay, yeah. So the next question he has is this like east-west load balancer? Well, actually, proxy can be considered as north-south load balancer. That is right. You could choose your own north-south load balancer, right? Actually, proxy could be one. It could also use Nginx and then adopt service mesh just for east-west load balancer. That's possible. But I do want you to think through, in that case, a lot of our customers are looking, in that case, they would actually run Envoy next to their HA proxy or Nginx. The main reason is if you want mutual TLS authentication, if you want the key and certs managed by service mesh from your HA proxy or Nginx to the other service in running, like the service A running in the service mesh, you have to kind of having a way to have manage that key and certs. You can manage that manually, or people just run Envoy next to Nginx or HA proxy, so it can help them manage the key and certs, so it can establish mutual TLS from the HA proxy or Nginx to the service A. Any other questions?
Lynn, over in chat, Colin Griffin had a question, and then Carlos Arturo had a question as well. Not sure if you can see. Would you like to go ahead and move forward with the demo, and then maybe we can come back to questions, or?
Yeah, I can quickly show the demo for a few minutes.
Sure.
So,
yep. Okay, go ahead.
Yeah, so in this environment, you can see I probably have Istio already installed. I actually have all the add-on installed. So what we're going to do next is, by the way, this is the workshop. If you're interested in attending, you can sign up at solo.io. So what we're going to do next is deploy a simple application into Istio in action namespace. So it has web API recommendation, purchase history, and sleep. So 4 set of applications. So if you go to get pods, and if you go to Istio in action, you can see, all my all my pods are running. Remember, we talked about the first step to adopt a service mesh is adopt at the edge. So what we're going to do is expose our application to the gateway. So we talk about gateway resource, right? Through gateway resource, you can specify like the protocol, port number, your host name, your hosts, and virtual service really it's like a route rule. So virtual service specify, you know, for this particular host, by the way, it's binding to the gateway through here. And I want to route to the destination of web API service in Istio action namespace on port 8080. So let's go ahead and apply this two configurations we just viewed. Now, let me set my configurations for gateway IP. So essentially, it's grabbing the service load balancer service IP for Istio ingress gateway, and we're using port 80 because for non-secure and secure for 443. So now I should be able to reach out my application web API. So you can see really simple application, and I expose it on Istio ingress gateway through virtual service and gateway resource. Now I can access it, and I can, you know, view my configurations for the routes I just specified. And I can drill down to the detail of my route configurations. So this is really Envoy configuration. And this is why you can actually see values of Istio, because this configuration of Envoy is very hard to get it right. Where Istio configuration is what we showed earlier, it's much more simplified. You can also configure mutual TLS with you know, on the gateway or TLS on the gateway. So what we're going to do next is we're going to create a secret called Istio in action cert. And we're going to, you know, reprogramming our gateway resource, because we're going to enable TLS. So, and what we're going to do next is we're going to apply this updated gateway configuration. And notice here, we actually disable 80 now because we don't want port 80 HTTP continue to be allowed. So now if you actually do port 80 to access, you're going to be refused, right? Because we actually reprogramming Istio ingress gateway to not allow 80 and only allow 443. Now you can see if I'm going through there on the secure port, I can continue allow. So this shows you a snippet of one of our lab in this one, just to adopt Istio for ingress gateway. And we have many other workshops that shows adopt Istio for secure communication among your services, to do traffic shifting, increase resilience, adding external services, and also deploy Istio to production. So Todd, back to you. I know I ran a little bit longer.
No, you're fine, Lynn. Let me see. Let's see. Okay, yeah, we've got about 6 minutes or so. Let's see. Colin Griffin had a question he posed in chat. Is there a minimum resource buy-in? Let's see, to adopt this in my Kubernetes clusters or K8 clusters, what does it look like from a compute resource cost investment? Is there any guidance on that or any kind of general info?
Yeah, that's a great question. So you definitely need to budget resources for that. You also want to do performance test of Psycha latency, right, as part of your request flow. So typically, I think the impact are very minimum. So in Istio, we actually publish performance numbers. So if you want to take a look, definitely check it out. So I believe the latencies are milliseconds, 1 milliseconds around that. So check this out. And also you can budget for CPU and memory for your sidecar yourself. So if you look at So in my environment, I didn't inject sidecar, but if you do inject the sidecar, what you can do is you can check out the minimum CPU and memory that we config for you, and then you can adjust based on your needs. So we want you to budget that, right? So you look at the default one. We want you to start with the default CPU and memory we recommend, and then budget that for each of your services.
Okay, let's see the final question, Carlos. Is it a possible feasible scenario to orchestrate 2 or 3 service meshes, kind of ending with meshes of services meshes? I think I read that. Yeah, is it possible or feasible scenario to orchestrate 2 or 3 services meshes or service meshes?
Yeah, so that's actually a really good question. We do have users, for example, right? Because people are already using AWS Cloud, and AWS Cloud provide their app mesh, right? So when they are using AWS Cloud, their preferred service mesh may not be Istio, they may be, app mesh, because app mesh is provided free for them. And it's well tested for them. But if people switch to use other cloud or maybe on-premise, they would prefer an open solution, a more mature solution. Maybe they land up on Istio. So it's possible that user might choose to land up on different service mesh solution, depends on their scenario and business needs. This is why some vendors, even like Solo, we're building solutions that allows you to orchestrate among multiple services, service meshes. So if you go to our site, for instance, we do provide scenarios of that, well, you may run Istio on one cloud and maybe run app mesh on another cloud, and we provide an abstraction on top of Istio and other service meshes. So you would be working with our abstracted API. Does that make sense? So you could build your own abstraction, or you could rely on a vendor who already built the abstraction for you if you're interested to deal with multiple service meshes.